We are finally starting what I would say is probably my number one passion in science, which is chemistry. So we are finally starting real chemistry, and we have a little activity to go with this. So first of all, I want you guys to prove to me that you already know some stuff about chemistry. So we are starting with the atom, which is the basic building block of science. We'll talk more about the history of this later, but for our activity today, we're just going to do the very basics. So what I've done here is I've created a chart of subatomic particles. What would you guys say the prefix sub means?
Subway.
Not Subway, but I wish I could eat fresh today.
No, Subway though.
Where does a submarine go?
Water.
Under. Yes, you got it. So, a submarine goes below water. Subatomic is below the atomic level. So these are the particles that make up an atom. So, does anybody think they may know one of the particles that make up an atom? The small things on the inside.
Atoms.
Oh, don't kick this.
My bad. I didn't mean to.
Air, no.
You said neutron.
Neutron. That's one of them. Proton. Let's start with proton.
I knew that.
I thought a crouton.
Yeah, croutons.
Croutons are tasty, but those are not part of the atom. My wife makes homemade croutons.
Are they good?
Hold on, we'll do one at a time. Hold on. What?
Oh, geez.
These are all, nucleus would be where some things are located. A proton. Where would you find a proton? You're right. Say it again. In the nucleus. The nucleus is the center, most massive part of the atom. What's the charge of a proton? If you're pro or for something, you are positive. Okay, now we're on the right track. Now we're on the right track. Okay, what about another one? Neutron. A neutron. Oh, you know what? Let's add one more little thing here that says symbol. Because I like to give each one of these a symbol. I don't know why I wrote that there. Symbol. So when I say proton, a lot of times you're going to see me write P+. All right? So my symbol for a proton, P+. Where would you find a neutron? What were you going to say? Also in the nucleus. You're going to find a neutron also in the nucleus. What's the charge of a neutron? See, you want to say negative because neutron starts with the letter N. All right? But neutrons are from kind of the root word of neutral. And if you're neutral, do you care?
No.
So what's your charge? No. 0. No charge. A neutron is neutral. It has no charge. Symbol. Any guesses? N0. Man, you guys are smart.
I'm not smart.
Little, lowercase n, lowercase n. Well, it's kind of like a superscript. Yeah, I asked you to add a little column for a symbol. There's one more. You guys are forgetting one more. Electron. Where would I find an electron, Briley? Let's put outside slash orbitals.
Orbital?
Orbitals.
It is negative.
Orbitals. And that is our negative charge. It's our negative charge. So we're going to find our electrons outside of the nucleus, kind of in the rings or the orbitals. Guess what my symbol is for electron?
E negative.
E minus. E minus. Okay. So, if we were going to draw these, which you're going to be drawing a couple of these today, how does this look? In the nucleus, I have my protons, and I have my neutrons. So I would write how many protons, how many neutrons, and then I've got 4 rings. You must memorize how many electrons go in each of these 4 rings. Any guesses of how many go in the first ring? 2. So I have 2 in the first ring. Any guesses for the second ring?
4. 8.
2,
1.
3,
We're just yelling out random numbers. 8.
8.
It goes 2, 8. What about in the third ring? That's what you would think.
14.
No.
36, 7.
It's 8 again. So it goes 2, 8, 8.
2. This time
2, 8, 8.
It is 2.
That's almost my
There's
phone.
no way.
Oh my god.
This is almost my phone.
What you got to memorize is 2, 8, 8, 2. 2, 8, 8, 2. 2, 8, 8, 2. You can remember that. All right? 2, 8, 8, 2. This is really important. It's really important. So, electrons in the orbitals, 2, 8, 8, 2. I'm starting them on their path today.
I love that. Bring it.
This the first day. I told them this was one of my most exciting days. Just the basics. What's up?
Are there hot plates in the Earth lab?
Yes.
Where would they be located?
I don't know, but Mr. Knight would know.
Okay, because that's what Karen told me. He said, I believe there's something
They are.
that will save me.
We have a set in the Earth, Chem, and Bio.
That's very exciting.
Kind of awesome.
Yeah, because now
Yeah.
I don't have to put them on a cart.
I know.
That's gorgeous.
I know. Isn't it beautiful?
I am so impressed.
Their first day of chemistry. I know.
It's momentous, friends.
Tomorrow I get to hand them their periodic table, but I hand
That's a
it,
big day.
but I hand it out individually because I want to make eye contact with each person as I hand it to them.
Oh, it's like you're getting your diploma.
Yes. Yes.
It's the key to the universe.
It is. It really is. Yeah. 2 big days. 2 big days. All right. Let's move up. Let's move up. All right. So down here, this is what helium looks like on the periodic table. Up here. You will see helium
Over there.
right up here in the top right.
Number 2.
He. He is helium's what? Symbol.
Symbol.
All right? So we have a couple other things. First of all is this number. This number is called the atomic number. What does that tell us about an element?
Something atomic.
You've done this before.
It's the second.
It tells us 2 things that are equal to each other. It's from the chart above. 2 of those things above on the chart that you just wrote down on your notes.
Proton.
Number of protons,
Oh.
not neutrons, electrons. Because my protons and electrons should be equal to each other because all atoms should be neutral unless you make an ion, which we're going to do that today. So how many protons does helium have?
2.
How many electrons does helium have?
2.
2. You got it. Over here, I have the average atomic mass. All right? This is the average atomic mass, this number. If I round that, that is called the mass number. So if I round the average atomic mass, that's called the mass number. What would this number round to? 4. So my mass number here is 4. That's called the mass number. Shh.
What's up?
Hi. So the mass number is the number of protons plus the number of neutrons. So protons plus neutrons. So based on that, we could determine the number of neutrons in an atom. So look at what you have here. Look at what you have here, and tell me what would the equation be to figure out the number of neutrons. The what minus the what? Protons, which is the,
Atomic number.
well, first it's the atomic number, which I subtract that. It's going to be the mass number minus the atomic number. So if I asked you, how many neutrons does helium
6.
have? What's the mass number?
Oh.
4.
4.
What's the atomic number?
2.
What's 4 minus 2?
2.
4 minus 2 is 2. Okay. Take a look at this.
What is it?
It got a little weird on the copy on the back, but that's okay. Flip it to the back first. So on the back, it helps us review what we just talked about. Yes?
Oh.
On the back of the other one. Okay. So atomic number is the number of... Look at your notes.
Dang.
Protons
That's what I said, proton. Electron.
and electrons, but what we really care about is protons. Mass number is the number of protons and neutrons. The atom is if, I should say if. Does yours look weird like this to copy weird?
Yes. That's pretty cool.
If.
You should do that every day.
I didn't do that, all right? If the atom is electronically neutral, the number of what has to equal what? The number of protons has to equal the number of electrons. Remember, protons have a positive charge, neutrons have no charge. All right, protons and electrons will cancel each other out because protons are positive and electrons are negative. So here's what we're going to do today. We are going to build some atoms and ions. So you're going to want one person to have this on this side, and the other person needs to have it on the front side.
You know the two papers attached, right?
Take a look at the front.
I know.
On the front, it tells you what we are looking at. Do you have Smarties, Skittles, and Nerds? Great. It says, using the candy, create the different atoms listed below on the diagram. We're going to do these one at a time on the reverse side. That's why you have two people in a group. Okay? So the first one, notice, it says Smarties are electrons. So where are my Smarties going to go? On the outside. Skittles are protons. Where are those going to go? In the nucleus. And nerds are neutrons. Where are those going to go? In the nucleus.
There's a lot of nerds.
So here we go, letter A. What you're going to do, you and your partner are going to make this. When you think you have it, you're going to raise your hand. I'm going to come check it. If I say yes, pause. I'm going to show you how to draw it after that. If I say no, I'm not going to tell you what's wrong. You have to try to fix it. So right now, letter A, create a neutral lithium atom. And I'm telling you, it has 3 protons, 3 electrons, and 4 neutrons. Make that with your candy now. Raise your hand when you think you got it. So you have to open up your candy and actually do this. Electrons don't go in the nucleus. Neutrons don't go on the outside. Why do you have electrons in your nucleus?
Give me.
Skittles are electrons. Yes.
I don't have Skittles.
Huh?
I don't have Skittles. Or am I working with them?
You're working with them.
Okay. So what do I do?
Oh,
with
shoot. I didn't know.
these?
Huh?
What do I do with these? I just hold them?
Just leave them there.
Okay.
Let me know when you think you got it.
They go in there. Very careful. Because look. Where'd it go?
Let me know when you think you got it. Nope. You have protons on the outside and electrons on the inside. Think about how the electrons organize.
How do I?
What about now? What about now?
Nope. That's not how they organize. Look how many go in the first ring, second ring.
Oh, there's not a numbers.
Why do you guys have those all dumped there?
Caden.
You only need 4.
Oh, when you
Yes. Yes. You think this is right?
No.
How many electrons are in the first level?
We did?
How many in the second level?
8.
No, but how many do you actually have?
1.
That's correct. Don't, so keep that, pause.
Right?
That is right. How many, the last thing you have to think about is your electrons.
No, no, it's not.
How many go in the first level, second level? That matters.
Mr. Miller, this is so confusing.
Yes.
The nerd, you got 4.
How many electrons can go in the first level?
I don't know if it's counting.
Now you got it. You guys got it? Yeah. Where's your? I gotta see it.
Oh shoot, hold on.
Did you guys get it? Yes. So that means 2 in the first level.
But we don't have enough to eat them.
It's fine. That's how many it can hold. 1 on the second level. You got it. All right.
No, we did only gonna feel like.
Yes.
Okay.
Wait. Hold on.
Don't. Okay, so bye. Move it in.
That's great. Yes.
Okay.
Okay. You guys got it. So how do you draw this? Here's how you would draw this. In my nucleus, I have 3 protons, also known as 3 Skittles, 4 neutrons, also known as 4 nerds. The part you guys got confused on was the electrons. How many electrons do I have total?
3.
3. How many electrons can the first level hold?
2.
Only 2. Which means how many are going to go in the second level?
1.
That leaves 1 for the second level. So you should have had 2 Smarties in the first level, 1 in the second level. The 2882 is how many they can hold. They won't always necessarily be full. Got it? So now, B says make a lithium atom with a positive charge of 1.
Is this it?
Let me know when you think you got it.
I think I got it.
Let me Google the Bible.
Nope.
We
Alright,
have.
what about now?
Keep it on.
Huh?
What?
Nope.
Yeah, let's keep
What?
bringing them.
We only have 3 nerds.
Girl, you're about to. I don't know what that means.
Yes.
Explain. What's
Still lithium, but now I want it to have a charge of 1.
Wait.
Of positive 1. So change something with the candy to make it have a charge of positive 1. Well done. Don't tell anybody else.
Candy to make it a positive 1. Okay, so just go back to the charges. These are charges. Because they're.
You have to change something. Gotta change something.
What if I change these hard things?
You don't have to change. You really want to change one thing to make it have a charge from what you just had. Charge of 1. Yes. This has a charge of positive 2.
Do I have to break it in half?
No, because I have 3 positive and 1 negative. I want a charge of positive 1.
Hey, what about Mr. Hitler?
That's no longer lithium.
What?
Try something else. Yes. Yeah. Yes. No, that is not lithium anymore. That's not lithium anymore. It does have a charge of positive 1, but that's not lithium anymore. Yes. Yes. You got it. Yes.
We got a little dot here.
This has a charge of 0
Oh, okay.
because I got 4 positive, 4 negative. Also, that's not lithium.
Huh?
Oh, so
Yes.
we reverse it.
We got there eventually.
So do I take one of these with?
Yes.
Okay, I was.
You got it.
Okay.
Yeah.
Dang.
Yeah.
All right. So, here is what you wanted to do. All right. So, what you wanted to do, what was your first instinct to give it a charge of +1? What did most of you do?
Add a proton.
You added a proton. Take a look over my periodic table. All right. So, here's lithium.
Right.
Yes.
Right.
Yeah.
If I add a proton, is it lithium anymore?
No.
Now it's beryllium.
I don't know what that is.
What? What's what? The periodic table of elements? So I'm pointing at the atomic number of lithium. It's 3, right? That means it has 3 protons. Agreed? If you add another proton, it does have a charge of +1. But what you've also done is you've turned lithium into beryllium. You can't change the number of protons. You can't change the number of protons. But what you could do was change the number of what? Electrons. So when you are changing the charge, you've got to change the electrons. You've got to change the electrons. So to give it a charge of +1, what did you have to do? You had to remove 1 electron. This is really helpful to show me where not to put you for the new seating chart.
Why?
Because you're just talking the whole time.
Well,
So it's
I know
really
what I'm
helpful.
supposed to do.
I know, but like, I'm talking.
I'm sorry.
It's okay. So, I take away an electron. Is it still lithium? Yes. What is 3 positive plus 2 negative?
1 positive.
1 positive. So this is what you should draw for B. That's what you should draw for B. Are you guys getting it?
So this one has 9 protons.
So, for the last one, on C, I tell you what neutral fluorine has. In its neutral form, it has 9 protons and 10 neutrons. I'm sorry, 9 electrons, 9 protons, 10 neutrons. What I want you to do is make fluorine with a charge of a negative charge of 2. Make that now. Let me know when you think you got it.
10,
Make that now. Let me know when you think you got it.
5. Figure it out. And then
Gonna be a lot of Skittles and nerds in the middle. Proton down.
Put another row of 3. And then we need 10 more.
Get started. We have proton.
You're gonna make it with the candy.
Ah, okay.
I want to see it. Yes.
That's a lot of Skittles.
3, 6. Your Skittles are right. Your electrons are not.
We have 10 electrons in there. They're like under 8.
Those are nerds. Those are neutrons.
It's
Electrons are the smarties.
yeah,
Nerds and 3 Skittles.
10 neutrons, 9 electrons, 9.
Right now you only have 3 electrons.
Dr. Haller, I think we have it.
Hey, I think we got it.
Okay. So I have 3, 6, 9. I'm assuming your nerds are right.
Yeah.
6, 8. Well done. You got it. Draw it. Draw it. All right, let's
I already
see.
drew it.
So I have 3, 6, 8. That's not enough protons. You need 9 protons.
10. But then we need a negative charge.
So right now you have 2,
There's
4,
10.
6,
There's 10, by the way.
3,
We take away 2
6.
of these.
No, you can't change the middle.
No, we took away 2 of these. Remember the Smarties?
So right now this has 2, 4, 6, 8. That has a charge of -1. I want to charge a -2. Oh, now it has a charge of 0.
What the heck? We add 1. Add 1. Add 8.
You're on the right track? Yes. So that is lithium. I'm sorry, that is fluorine, but you only have 4 electrons. This currently has a charge of 9 minus 5. Has a charge of +4. I want to charge of -2. 2, 4, 6, 7. That has a charge of 3. That's not fluorine. Because you only had 3, 6, 7. Not fluorine. Yes. So you have 2, 4, 6, 8. This currently has a charge of -3.
Oh my gosh, what are we doing?
Now you got it.
Yay.
Now you got it. So draw it after you got it. You guys think you got it? How many in the first level? 2, 4, 6, 8. Yes. You got it. Yes. Okay. 2, 4, 6, 8. Yes.
Is that actually right?
Yes, that's right. You got it.
Oh my god.
All right. So on this one, fluorine has how many protons? 9 protons. Can I change the number of protons? No. How many neutrons does it have? 10. Do the neutrons have anything to do with the charge? No, because they have no charge. Right?
Yeah.
And I said I wanted to have a charge of what? -2. In order for this to have a charge of -2, how many more negative charges do I have to have than 9? 2. So how many electrons do I need to show? 11. How many can the first level hold? 2. How many can the second level hold? 8. Leaving how many for the third level? That is an ion of fluorine.
Can we do another one?
Fluorine gain 2.
Another one.
What?
You should do it.
Oh, just eat your candy.
No.
All right? That's it for the day.
This is fun.
It is fun, but if you want to do it on your own, you can. If not, just eat your candy. No, you got to share with your partner. I have to make these last all day. So, nice work. That's all I got. You guys can hang out the rest of the time.